Welcome one more time to my YouTube channel. Today we're looking at kinematics. This will be our first video under the playlist of physics. This will be the first topic we'll be treating, kinematics. So if you're new to this channel, please subscribe, click on the like button and the notification button so that you get notified whenever I drop a new video. So let's move in now. So what is kinematics? So kinematics is the study of motion without reference to the cause of the motion. I hope you understood what I said there. Here we will consider the motion of a particle in a straight line only. Such motions are called rectilinear motion on a straight line. So we can consider the motion of a car or a train in the same way as we would consider the motion of a dimensionless particle. So before we go further, we have to make distinction between these two quantities, vector quantity and a scalar quantity. When we have a clearer understanding of these quantities, we can now forge ahead. So what is a vector quantity? A vector quantity or vector quantities are quantities that has both magnitude and direction, and such quantities are displacement, velocity and acceleration. While on the other hand, a scalar quantity or scalar quantities are quantities that has magnitude but has no direction. They only have magnitude but has no direction. An example of such quantities are distance, speed and time. Distance, speed and time. Okay, take note of that as we progress. Alright, under kinematics we will look at one where we would look at position. We will look at position. 2 we would look at velocity. Then 3 we would look at acceleration. So let's start by that. Now, what is position? Let's say position. What is position? Position, we can say position or a location of a particle in a given space. Okay, we can say the position coordinate of a particle moving. Remember, we're looking at motion on a straight line, moving in a straight line. Straight line is determined, can determine the position by its distance from a fixed point O, that's the origin. So remember, whenever we mention O, we're making reference to the origin, where the particle began the motion, the origin O. Point O on a straight line or a line called the origin. That's what I said, which can either be to the left or to the right. So don't worry, you would understand what I'm saying. Right of O. So the position coordinate of a particle moving in a straight line is determined by its distance from a fixed point O on a line called the origin, which can either be to the left or to the right of O. So what am I saying? Let me draw a line so that you would understand what I'm trying to say there. So let's say this is the origin, let's say O, the origin O, and we'll say this is P in the direction of X. So the position of this particle, let's call it Q, from point A to point B can always be determined from the origin. So let's say the particle is moving to the right, you can now say and stop at point O, so the position coordinates of this particle can be determined in this manner. So let's now look at under position. Remember, we're now looking at position. Remember that we would look at displacement. What is displacement? Displacement can be defined as the change in position, of a particle relative to O, that's the origin. So where X, the particle, now let's call the particle X here, is defined, the particle now is defined as the position of the particle, say X, is defined as a function of time. Hence we can say X of t is the displacement at time t. So to understand what I'm trying to say here, let's say consider a particle that starts at the origin 0 and moves firstly 5 units to the right to a point P, and then 7 units to the left to a point Q. So let's consider that particle. How is the movement? Okay, let's have a straight line so that we would understand how the particle moves. And then let's say this is our origin, pardon my drawing, O. Let's label this 1, 2, 3, 4, 5, 6, 7 this way, and then we have -1, -2, -3, -4, -5, -6, and -7. So we were told that the particle started at point O. The motion or movement of the particle started at point O, and it said that it firstly moved 5 units to the right to a point P. 5 units, that means we have 1 unit, 2 unit, 3 unit, 4 unit, and 5 units. This is the point, let's say P, as it was stated. And then it was said, let's now draw the movement this way. It moves this way. And then what is the question, the thing now said earlier? It now say 5 units to the right to a point P, which we've now drawn, and then 7 units to the left to a point Q. To the left, it now turned back this way. 1, 2, 3, 4, 5, 6, 7. This is our 7 unit at -2 to a point called Q. This is the end and this is the start. So this is now the motion of that particular particle. So we can now say the final position of the particle which we call X, position of X is equals to -2, and the distance the particle covered is 12 units. Do you concur? We moved 5 this way, and plus 7 we have 12 units. So that's that. Let's now pick an example and dive into it. And the question says a particle moves in a straight line so that its position x centimeter relative to O at time t second is given by x is equal to t square minus 7t. This is 7t plus 6 at t is greater than or equal to 0. The first question says find its initial position, and the second says find its position at t equals to 4. So solution A. At t initial, that's the starting point, t equals to 0, we now have x is equal to what? T square minus, this is t square, keep that in mind, t square minus 7t plus 6. Remember, at x equals to 0 initial, 0 squared minus 7 multiplied by 0 plus 6. Our final answer will now be x is equal to what? Positive 6. X will be equal to positive 6. That is, the particle is 6 centimeter to the right of O, to the right of the origin. So B now said we should find its position at t equal to 4. At t equal to 4, we have x is equal to t square minus 7t plus 6. X is equal to 4 squared minus 7 by 4 plus 6. We have x is equal to 16 minus 7. 16 minus 7 plus 16 minus 7, 4 plus 6. If you do that, this is 6. If you do that, you find x is equal to minus 6. So this means that is the particle is 6 centimeter to the left of, or to the left from, let's say from, to the left from O, to the left from the origin. So that is that. We have solved a problem on that position. So let's now look at, I said we'll look at 3 things: position, velocity, and acceleration. So this is just a pre-video into our physics class. I'll just be taking one example, but maybe when I get to acceleration I may take 2, but I don't know. Let's just go deeper. Let's take velocity now, look into it. We are now looking at velocity. The velocity of a particle is defined as the rate of change of its position with respect to time. That means the rate of change of a particle's position with respect to time is velocity. We can consider the average rate of change, that is the change in position over a period of time, as also the velocity of a particle. We can consider the instantaneous rate of change as velocity, which specifies the rate of change at a given instance of time. So at each given interval of time, at a given instance, we can always calculate or find the velocity of a particle. So if a particle moves, let's say, from x1 at time t1 to x2 at time t2, then its average velocity can be termed as x2 minus x1 over t2 minus t1. I hope you understand what I'm saying. Let me repeat myself. If a particle moves from x1 at time t1 to x2 at time t2, then the average velocity can be calculated using this formula. That's x2 minus x1 over t2 minus t1. But there's something I want you to note very carefully: the difference between velocity and speed. Speed is just a magnitude of velocity. Get the distinction. Velocity of a particle is just the rate of change of position with respect to time, while speed is just the magnitude of velocity. I hope you get the difference clearly now. I hope you get that clearly. It's very, very important you get that. We have gotten average velocity as average velocity. Note average velocity still was x2 minus x1 all over t2 minus t1. So now we can say average speed average speed for a time t1 comma t2 would be what? Would be equal to the distance traveled all over t2 minus t1. You see the difference now. And in the same manner, we can say instantaneous velocity. The velocity of a particle at every given instance can be calculated as v is equal to the t, rather dx over the t, where x is a function of time. I hope you understand that very, very well. Instantaneous velocity we said is the velocity of a particle at every given instance of time. So let's now consider an example. The question says a particle moves in a straight line so that its position x centimeter, this is centimeter, x centimeter relative to O at time t seconds is given by x is equals to t squared minus 7t plus 6 at t greater than or equal to 0. So the question says A, find its initial velocity when and where its velocity equals to 0, C, its average velocity for the first 4 seconds, and D, its average speed for the first 4 seconds. Let's proceed. Let's now say A, x is equals to t squared minus 7t plus 6, where we said V is equals to the x over the t is equal to, we're now differentiating, right? Now I have 2t minus 7 plus 0. Now V is equal to 2t minus 7. This is 2t minus 7. Now at t equal to 0, we have V is equal to 2 open bracket 0 minus 7. Then V is equal to minus 7. That's our final answer. So that means that is the particle is moving to the left at 7 centimeter per second. So we have solved for A. Let's now go and solve for B. B says find when and where its velocity equals to 0. We now have 2t minus 7, remember, is equal to 0. Remember that. So 2t now is equal to 7. We'll take 7 to the other side. We have t is equals to 7 over 2. Hence t is equal to 3.5 seconds. So when t equals to 3.5 second, x equals to t squared minus 7t plus 6. We'll now have x equal to 3.5 squared minus 7 times 3.5 plus 6. Putting this all together, now have x is equal to minus 6.25. This means the particle is 6.25 centimeters to the left, because we're having minus there, left of O at t equals to 3.5 centimeters, 5 seconds, not centimeter, rather 5 seconds. So that's that. Let's go to C. What did C say? C says we should find its average velocity for the first 4 seconds. So average velocity, as we said earlier, is equal to change in position all over change in time. So remember, at t, they said at t equals to 4 seconds, x, and this is 4 seconds, x is equal to 4 squared minus 7. We're substituting now 4 for t in the equation. Keep that in mind. X is equal to 16 minus 7, 4 plus 6. When you put this all together, you would have x equals to minus 6 as I have it here. Hence, average velocity is equal to, what we have, the change now would be what? Remember our formula. The change will be 6 minus 6 minus plus 6 all over 4 seconds. That's our change in time. This is our change in position. So average velocity, AV velocity, is equal to minus 3 centimeter per second. So that's that for C. Let's say D. What were we asked to find? We are asked to find its average speed for the first 4 seconds. Looking at our equation, what do? Since the particle from where we calculated before stopped at 3 seconds and began to move at 3.5 seconds and began to move in the opposite direction, we must consider the distance traveled. Alright, before I proceed, let me just draw it so that you will understand. We know that the particle in B, x, traveled, we got negative 6.25 when it traveled. When it started traveling, it reached that negative 6.25. So it traveled and it reached here. Then 0.25 would be 1 over 4, that's quarter. Then would add it up, 1 over 4, and then it now retardated back again to 6 at t is equal to 4. So that means the interval here now was at 0.25 seconds. So since the particle stopped at 3.5 seconds and began to move in the opposite direction, we must consider the distance traveled in the 3.5 seconds. That's from x equals to 6 to x equals to 6.25, and then the distance traveled in final 0.25 seconds. That's when it turned over here. This distance is covered back in 0.25 seconds. So the total distance now, total distance traveled, that's from, let's call this point P, let's call this point O, let's call this point R, let's call this point Q. So the total distance it traveled from 0 to P, back to R, now is equal to 12.25. It started traveling from 0 to P, and if you add it up, this plus this would give you 12.25. Alright, so that would be plus what? The distance from R to Q, this mini distance here from R to Q here, which is what? From R to Q is 0.25. So hence the total distance traveled now would be what? 12.5. So average speed now is equals to 12.5 all over what was it? 4 is equal to 3.125 centimeters per second. So that's that. Let's now move into acceleration. So we're now looking at acceleration. We say acceleration is the rate of change of velocity with respect to time. So average acceleration for a time interval t1, t2 is defined by v2 minus v1 over t2 minus t1, where v2 is the velocity at time t2 and v1 is the velocity at time t1. So similarly, instantaneous acceleration A is defined by the v over the t, where we say d over the t would now be open bracket d x over the t, which our final value will now be d square x over the t square. That would be our instantaneous acceleration. So you can just look into that. I would just dive into a simple example. This is the question. It says a particle moves in a straight line so that its position is defined by x is equals to t squared minus 6 t squared plus 5. This is plus 5 when t is greater than or equal to 0. Find its initial position, velocity and acceleration, and hence describe the motion. B, the time when it's instantaneously at rest and its position and acceleration at those time. So how do we do this? Let's just go straight. V is equal to, this should be 3, sorry, this is 3, this should be 3 t squared minus, correct it in the question please. This is supposed to be squared, 12t plus what we have here, 0. So v is equal to what? 3 t squared minus 12t. So what will now be our acceleration? Acceleration will now be another derivative of this. A will now be equal to 6t minus 12. So at t equal to 0, initial position will now be x equal to 0 cube minus 60 squared plus 5. So x, if you solve it, now be equal to what? 5. So that's that. X will be equal to 5. If we now go back to our velocity, we remember that v is equal to 3t squared minus 12t. We substitute it for 0, v will be 3 0 squared minus 12 0. V is equal to 0. So similarly for acceleration now would be a is equal to 6t minus 12 a is equal to 0 minus 12. So a is equal to minus 12. So we can say the particle is instantaneously at rest 5 centimeter to the right of 0 with an acceleration of minus 12 centimeter per second. So that is that. So we will now calculate for B. B says let's calculate or find the time when it's instantaneously at rest and its position acceleration at those time. Remember, we have V equals to t squared minus 12t is equals to 0. So V is equal to 3t, let's open bracket, say t minus 4 equals to 0. We will say 3t is equals to 0, and t is equals to 0 minus 3, t is equals to 0, or t minus 4 is equals to 0, t is equals to 0 plus 4, t is equal to 4. Remember, if you expand this, you would have 3t squared minus 12t equals to 0. I hope you understand that. So let's now dive into the last thing. Remember, the particle is initially at rest and it stopped again after 4 seconds. So at t equals to 0, comma x was equal to 5, right? So now at t equal to 4, what do we have? We have x open bracket 4 cube minus 6 open bracket 4 squared plus 5. So x is equal to what? If we calculate, you would have x equal to minus 27. So that's that. Let's now look at the acceleration. So at now acceleration when it was equal to minus 12, now say a is equals to 6t minus 12. Now a is equal to 6 4 minus 12. A is equal to 24 minus 12. A is equal to 12. Hence we can say after 4 seconds the position of the particle is 27 centimeters. Is 27 centimeters. Is 27 centimeters to the left because it's negative of O, left of the origin, and the acceleration is 12 centimeters per second. So that's that for today. Let's now dive into motion, where we would look at the 3 equations of motion. So just stay tuned. We're now looking at motion. So let's imagine an object traveling with a velocity, let's say v meter per second. If the object experiences an unbalanced forces, it will cause the object to accelerate at an acceleration, let's say meter per second square. The force that acts on it will be for a given time. So the force acts for a time t, so the acceleration now would last for a time t. So after t seconds, the object will have a final velocity, say v meter per second. So what am I saying? Let's have a look at this time graph. Let's say the object start moving. Let's imagine that the object starts moving here. This is its initial velocity here on this graph u. It start moving, as the time increases. Let's say this is 1 minute, 2 minutes, 3 minutes, this is 4 minutes, 5 minutes. So as the time increases, the velocity also increases, and this is its starting point, the initial velocity. So when the object now stops here, let's say at time t, it will have a final velocity here, say v meter per second. So having done that, let's move further. Let's now derive the equations of motion. Looking at this, let's draw this. Say v meter per second here. This is time t, this is t, this is u, this is o, going this way. So it's going this way. So the gradient now, the gradient of the velocity time graph. This is a velocity time graph. Velocity time graph. The velocity up here, this is time at the x-axis. Time graph gives us the acceleration a. So now we can see gradient is equal to change in velocity all over time. Its gradient would be equals to v minus u over t, which now means gradient, we say, is our acceleration, is equals to final velocity minus initial velocity all over time. So that's that. Let's now say we're now looking for the first equation of motion from here. So what do? We now multiply both sides by t. Let's multiply both sides by t. Doing that, we have at is equal to v minus u over t multiplied by t. So t and t now will go. We would have at is equal to, let's say this is 1, this is 2, and this now would be at v minus t, equation 3. Having done that, we can make v the subject. Make v the subject of the equation. Doing that, we have v is equal to u plus at. So this now is our first equation of motion. We call this equation 4, and we can call it our equation 4. So let's now move forward. Displacement s of the object. So how do we get that? The simple way to calculate is we now divide this way. Let's now do it this way. Let's split this so that we would have different shapes. So you can see from here, this area now, let's say this to this portion. If we divide this here, you see we have a triangle. Let's say this is our shaded side. This is our shaded side. Dividing the shaded side would now give us 1, a rectangle, and 2, a triangle. So we now have a triangle and a rectangle Hence, the sum of these two area, that's area 1 rectangle, is equal to area 1, let's call it area 1, and triangle is equal to area 2. The sum of these areas now will be equal to displacement. So note the sum of area 1 and 2 is equal to our displacement S. So let's now go deep. So we have a rectangle and we have now a triangle. So let's now consider area 1. Area 1, a rectangle. What's the area? So the area now would be what we have ut. Area 1 would now be equal to u multiplied by t, which is equals to ut. You see that? So our area 2 now would be equal to the sum of it. The area of a triangle, sorry, is what? Half base times height. So that's that. So considering the triangle now, you would see that our height, we are finished for this. So we can say this is our equation 5. So let's now redraw our triangle. Let's redraw the triangle here. I have v meters per second, and we started at where? At our initial velocity u. So we went this way. We now went this way, right? This is t time. This is t. This is time. So this is our height. Our height now is what? Our height here would be v minus u. That's our height, and our base would now be what? The base is equal to t. So having done that, now we can say area is equal to 1 over 2. Base is what? T times our height is what? V minus u. Let's say this is equation area 2, equation 6. So we now have that. So remember, we said area 1 plus 2 would give us what? Would give us our displacement. So we're not yet done here. Remember, from equation 4, a was equal to at was equal to v minus u. So we substituted back into 6. So area 2 is equal to 1 over 2 t multiply by what? Multiply by at. Multiply by 80. That's equation 7. So hence the area 2 now, area 2 will be equal to 1 over 2 at squared. Let's call this equation 8. Therefore the total displacement now, is equals to area 1 plus 2, which is equal to what? Which is equal to area 1 was what? Area 1 was ut plus area 2 was half a t squared. So s now will be equal to displacement u plus a t squared. So 9 This is our second equation of motion. This is our what? Second equation of motion. I hope you're getting it well. So let's now dive deeper and see if we can get the third equation of motion. Note, let me say note, both s equal to ut plus half at squared and v equals to u plus at include the time variable. They both include the time variable. So there will be a situation where we do not have an information about the time. So if that happens, it would be good, or it would be a good idea to derive the equation so that we do not have a t time. We just drive the equation forwardly, neglecting the t time. So how do we do that? We can say from v is equals to at plus u, we now what? Make t the subject. We now exclude the time variant while calculating t equal to. It will be good we do it this way, all over a. So let's say this is equation 10. This is equation 10. So how do we do it? We now substitute equation 10 into the second equation of motion, which is s is equals to ut plus half at squared. We substitute it into that. Alright, let's substitute and see, but let me clear this so that we have a much bigger space. We'll now say s is equal to, we have u. We said wherever we see t, we substitute t equals to v minus u over a. I hope you're following. So we have v minus u over a plus 1 over 2 a, or open bracket v minus u over a. Remember here is squared. So we now take out a. Let's say take a out of the bracket. So how do we do that? We say s is equals to u, open bracket v minus u over a plus 1 over 2 a, this bracket v minus u squared all over a squared. We've now removed it out of the bracket. So what do we do next? We cancel out the term, cancel out the terms. So how do we cancel out the terms? We say s is equal to u v minus u all over a plus 1 over 2, and we cancel out the terms, 1 over 2 over v minus u squared over a. Remember, a goes with a, we have a remaining. So what do we do next after cancelling out the term? Let's now say, let's remove fractions by multiplying both sides by 2a. Let's multiply both sides by 2a. Let's now say both sides by 2a. Well, now 2as is equal to, we have 2a here by u v minus u over a plus 1 over 2 v minus u squared multiplied by 2a all over a. But remember, we can still rewrite this particular side as this: 2as is equals to 2a by u v minus u over a plus v minus u squared all over 2a times 2a, so that this and this goes, this and this goes. So if they go, what do we have left? This is 2as. We have 2as is equal to 2u open bracket v minus u plus what? V minus u squared close bracket. So that's what we will have. 2as, by expanding this bracket, we will have 2uv minus 2u squared plus v squared minus 2uv, yes, plus u square plus u square plus u square. Let's now rearrange. By rearranging, we would have 2as is equal to 2uv minus 2uv plus v squared minus 2u squared plus u, where this and this goes. If this and this goes, let's now have a more cleaner side to work on. So we said this and this would go. Remember, minus plus will remain 1 here. We have 2as is equal to v squared minus u squared. So we make v squared the subject of the equation. By doing that, we would have v square is equals to u square plus 2as. So this now would be our third equation of motion. So we will be stopping here, but in our next class we'll be seeing some practical examples or calculation examples where we can play with these formulas, but the three equations of motion. So but before we go, let's have a recap. Is equals to u plus at, which we say is the first equation of motion. This is what we said is the first equation of motion, and we said that the second equation of motion, which s displacement, was s is equals to u plus t plus half at squared. We said this was the second equation of motion. And lastly, we said, just the one we calculated lastly, v squared is equal to u squared plus 2as. We said that this was the third equation of motion. So this is just an introductory class to our physics. Subsequently, we would go deeper, but our next video would be on the examples under equations of motions, where we will see how we would use both the first equation, the instances we would use the first equation, and the instances we would use the second equation and the third equation. So if you haven't subscribed to this channel, please subscribe, click on the like button as well as the notification button, so that you can be notified whenever I drop a video. So watch out for the second class of our physics. But if you're an electrical student or you have problems in electricals, there are videos I've dropped out there for the electrical series. You can do good to check them out. So thank you, have a nice day.